All right, so we're continuing on with our, oops, that's not what I wanted. With our work on inverse trigonometric functions. Do you guys remember that little half sheet that's kind of beige in color that we colored up with the markers the other day? I want you to make sure you have that out. It should look like something like this with maybe 3 colors instead of 2. But remember, when we're working with arcsine or arctangent, we are looking at just these quadrants and measuring from negative pi over 2 radians to pi over 2 radians. If it's arccosine or inverse cosine, you're measuring from 0 to pi. And those are the only places you can look, and we have to be really careful how we're naming those angles. One thing I didn't make a huge deal about whenever we taught this, I feel like it was a week ago, but it wasn't that long ago, I don't think, is tangent. We'll look at the graph in a minute, but remember tangent has asymptotes, so tangent is undefined at the endpoints of this interval. So when you look at inverse tangent or arctangent, you have to be careful about the endpoint parts here, the negative pi over 2 and pi over 2. We're going to see an example coming up in this next composition section where we find out that our problem is not possible. So, spoiler alert. All right, here we go. So we are on, nope, not that. It's going to talk to you about composition of trig functions, and we have to be careful whether it's asking us an inverse tangent question or a tangent question or a sine or cosine. And we have to remember the domains for which they're defined. And this is the point that I would like you to highlight that I did a terrible job of talking to you about. I don't know if this is on your paper. It's somewhere on your paper if it's not on this slide. But this part right here. Notice how the inequalities don't have equal to bars on the pi over 2 and the negative pi over 2. That's what I need you to remember. There's one question coming up where it's really nasty. I'll tell you, I probably won't test you on those nasty questions, but I know this is a concept that you need for calculus next year. All right. Let's take a look at some examples of composition. So, number 11. For a lot of algebra kids, they look at this and they go, sine, inverse sine, I feel like they should just cancel each other out. And sometimes that is exactly what happens, but just trust me when I tell you these are a little trickier than they look. So you have to go through the same process every time, because you're aware that these could be nasty. So the first question says, where is the sine value equal to negative 3/4? Well, the first problem we do is we look over at our unit circle and we realize nowhere on the unit circle. But remember, the unit circle is just a collection of frequently used radian measures, definitely not all of our radian measures on the planet. So what we're going to have to do on this question is actually sketch it out. So I think about where arcsine is defined, which is from negative pi over 2 to pi over 2, and I'm going to draw myself a little triangle. So which quadrant are we looking in if it's a sine of negative 3/4? Can't be in quadrant 1, so it must be over here in quadrant 4. So draw yourself a triangle and label the sides of the triangle that go with the sine ratio, which is, remember, it's y over r. So the y value I'll call a negative 3. The r we'll call a 4. So that's the triangle we're looking at. I could find the x value if I wanted to. But now it says, for that angle measure, which you can call whatever you want, they usually call it alpha in your book, I think, instead of theta. Not really sure why. It says, what's the sine of that angle? Well, guys, this is not really that complicated of a question. What is the sine of that angle? What's the sine ratio for that angle? Is it negative 3/4? So in that case, the sine and the arcsine function did, like algebraically, it looks like they just canceled each other out. But we have to be really careful of sines and quadrants on these questions. So I always suggest you draw it out. Now, the next few questions, you're in luck. You don't really have to draw anything out because they're things that come up on our unit circle. So starting on the inside of this composition question. This is not an this is not an arccosine question. This is just a regular old evaluate. What is the cosine value at pi over 2? Right off your unit circle. It is 0, so this is really a 0. So this question really says arccosine 0. So that's a way of them asking you, now be careful because we're on arccosine now, where is the cosine function, where does the cosine function give you a value of 0? Now remember, arccosine is just defined from 0 to pi. So you're like, this seems really stupid, because guess what the answer is? That pi over 2. Oops, 2. So again, you're thinking, Abruzzo, you've really overcomplicated this. Why don't you just tell me that the cosines and arc cosines cancel each other? Because they don't always just cancel each other. So let's look at this next one. Tangent at 3 pi over 2. So straight off the unit circle, what is the tangent value at 3 pi over 2? So remember, this is the ordered pair 0, -1. So the tangent of that would be -1 over 0, which is undefined. So this next part of the question says, where is your tangent function undefined? Now this is a confusing question because a lot of kids would look at this and go, well, at -pi over 2. But remember we talked about this a minute ago? Arctangent, where's that slide at? Arctangent is not defined at -pi over 2 because there's an asymptote there. So what you're going to have to tell me for this question is that it's not possible. Don't tell me undefined. Just tell me that it's not possible. And that's because of the domain and range restrictions that we've implied for arctangent. All right, this next one. This is a more traditional composition question. So we have cosine at pi over 6. I need you to pull that straight off the unit circle, guys. What is the cosine at pi over 6? Is it square root of 3 over 2? Okay. So this is the square root of 3 over 2. So now the question says inverse sine square root of 3 over 2. That is asking you where on the unit circle is the sine value of square root of 3 over 2. And make sure for arc sine you're only looking in the appropriate quadrants. What you got? Is it pi over 3? Okay. Now I think answering these, like really particularly, even putting the preposition at and labeling it with radians, I think that's going to help you out because these get really confusing because some of them are like direct evaluation questions and some of them are pulling off the unit circle, inverse arc sine. Yes. Is that positive square root of 3 over 2? Oh, are you asking for the second or first part of the question? Okay, so where is arc sine positive square root of 3 over 2? So it's asking where is the sine function, which is the y value, right? It's not positive, right? Yeah, you're looking at cosine, aren't you? I gotcha, yeah. And that's where it gets tricky, right? Because there's a lot going on, right? All right, so these are not super fun. They're a bit of a puzzle, like everything in our class, I feel. All right, so this one, be careful. They're switching it up on you. They're starting off with an arc sine question. So this question is asking where arc sine is defined, where do you get a sine value of positive 1/2? Okay, I heard at pi over 6. Yes, yes, confirm? Okay. So now the question really says, what is the cosine at pi over 6? Well, that's just a direct pull it off of the unit circle question. What's the cosine at pi over 6? It's square root of 3 over 2. Very good. So this is confusing, right? They're going to pop between inverse functions and regular functions, and you got to be careful about it. So taking your notes with these extra words, prepositions, labels, I think might help. All right, number 16. Start on the inside for these compositions. Arc sine -1/2. So where arc sine is defined, be careful please, and call it the right name. Where is your sine function going to give you a -1/2? At -pi over 6. Very good. So that's because of the definition of the restrictions on arc sine. So this question really says, what is the tangent at -pi over 6? So remember, tangent's the one that's not on your unit circle. You'd have to do a little calculation. What's the ordered pair at -pi over 6? It's square root of 3 over 2, -1/2. So coming up with the tangent ratio, you take y and divide it by x. Okay, I really ran out of room here. So y, instead of dividing by x, I'm going to multiply by the reciprocal of x. The 2's are going to cancel. And then, friends, please make sure you rationalize this ratio. -1 over square root of 3 becomes negative square root of 3 over 3. Fun times. Whew. All right, this next one. On the inside, says arc cosine 2. Seeing some confused faces. Why is that? Because cosine wiggles between -1 and 1. So when will the cosine value give you a 2? The answer is never. So you say not possible. All right. Number 18, start on the inside. Now careful, we're arctan this time. Make sure you're looking in the proper quadrants. You're only allowed to look from -pi/2 to pi/2. So I think we just found this. Where was the tangent ratio a -√3/3? That was at -pi/6, yeah. So now the question says, what is the cosine at -pi/6? And you tell me? √3/2, thank you. Nice job. Super fun, right? Yes, Mrs. Abruzzo, these are amazing. Alrighty. Let's go ahead and take a look at 21. Actually, hold on, back up a minute. Trying to see if there's a nasty one coming up. Okay. Yep, let's skip to 21. So 21's extra weird. There's composition and then there's like a random subtraction problem inside of the composition. So what I'm going to need you to do is kind of isolate the pieces of the problem starting on the inside. This first question says, where is sine? Is this the same one on your notes, by the way? Okay. Where is sine a 1? So remember, it's arc sine, only defined in certain spots, so be careful when you tell me the answer. Where is that the case? Where's your y value of 1? Pi/2, good. And then where is cosine? Make sure you're looking in the proper places for arc cosine. Where is cosine a 1/2? Is that pi/3? Okay. So what I'm seeing now is the question is, what's the tangent of pi/2 minus pi/3? Which makes me go back to 5th grade for a minute. I got to subtract fractions. What is pi/2 minus pi/3? I don't know. Say 3 pi/6. And this is 2 pi/6. So this is, what's the tangent of pi/6? Well, that's not really a bad question anymore. All right, so coming up with the tangent at pi/6, remember tangent is y divided by x. So that would be 1/2 times 2 over the square root of 3. 2's would cancel. And then, of course, you guys got to rationalize that. I've been skipping the math on the rationalizing step because I've noticed you guys do a fantastic job of it, but you know, if you want to see that rationalizing step in your notes, go ahead and do that. All right, can y'all find the next page of notes? It's 4.6 part 2, should be the next page. Alright, so day 2 on inverses. We're going to start off with a question that looks kind of like the question that we started with the first part of this lesson, where I'm asking you a composition question, but I'm asking you about something that isn't really on our unit circle, so we're forced to draw a triangle out on our own pretend little unit circle over here. So we're going to start on the inside, and it says, where is your tangent of -3/4? So remember where tangent is located for arctan, it's only in these two quadrants. So if it's a negative value for tangent, that means we're looking at a triangle down here. And I want to label the triangle's legs appropriately, so tangent, remember, is y/x. Just make sure you're careful where you put the negative sign, because remember in fractions, negatives can go anywhere. So if the y value is a 3, I'm going to go ahead and call that a -3 because it's going vertically down. And then x is a 4. And then you might want to employ some Pythagorean Theorem or a special right triangle pattern here. Or, sorry, not special right triangle. A Pythagorean triple pattern. This is a 3, 4, 5. But of course you guys could do Pythagorean Theorem. So now the question says, for this little measure here, which they're going to call alpha, I think, today instead of theta, they want to know what the cosine value is. So what's the cosine here? Well, guys, that's not really a hard question. Cosine is x/r. So that would be 4/5. So this question kind of feels like you have all the pieces working. You've already done a lot of these questions before. We just have to now understand the restrictions on our arc cosine, arc sine, and arc tangent functions. Of course, they get a little more exciting than that. I'm going to skip over this guided practice. Let's just get to your notes. Let's look at this question. This looks fun. All right, so the question is right here. It's kind of hidden in your problem, but it says, evaluate the tangent of the arc sine of A. So some mystery angle A. Clearly, A is not anywhere on your unit circle. So it's some mysterious angle, and we're going to do the same way where we start on the inside, but this time we're going to have to draw a triangle with the appropriate information. So on the inside here, it says the sine function is A. So think of it this way. Sine of A is, no, that's really confusing, guys. I apologize. Not A. Not A. They called it U this time. The sine of this angle is A over 1. Thank you. Why did I write it as A over 1 instead of A? Because sine by definition is a ratio. It's a ratio of, old school, opposite over hypotenuse, or now it's y over r. So this is your y value, this is your r value, and then the next thing they're going to do is they're going to draw a triangle. They drew it in the first quadrant because everything was positive, so for arc sine that makes sense. They filled out the vertical leg, the y as an A, the hypotenuse as a 1, and then they're going to want you to find out, eventually, the tangent of this angle. Well, the problem is, for tangent, you need to figure out that leg. So then we throw some Pythagorean Theorem your way, guys. I'm going to call this x. So Pythagorean Theorem would say x squared plus a squared equals 1 squared. And I need you guys to solve for x. So it's going to look really funky and algebraic, but that's okay. What would you do first to solve for x? You would subtract this a squared over, wouldn't you? I'm writing over my picture. That's terrible. All right, instead of 1 squared, I'm just going to call that 1. Guys, what would be your next step in solving for, or the final step in solving for x? You would square root both sides. So this leg, instead of calling it x, they're going to call it the square root of 1 minus a squared. Notice I didn't use a plus or minus symbol in front of that because of the nature of the leg going positive, so it's just positive square root of 1 minus a squared. So that's funky. So then they went old school, or new school, depending on you, and they said, how do you find tangent? What's the ratio for tangent? Well, old school is opposite over adjacent, but remember the newer formula you can also use is y over x. So here's y, here's x. They set up that ratio. But then why did they take that extra step to go to here? What did they do? They rationalized. Because math teachers are evil. So they hit top and bottom by the square root of 1 minus a squared. Yeah, these look really horrible, don't they? Because they're algebraic in nature. You can't really do a lot of simplifying. That's actually good news. The fact that you can't simplify makes your job a lot easier. Guys, that's probably the hardest question on here. So let's just do a few more and we'll call it a day. All right, here is this on? Yeah, it's on your paper. So towards the bottom, it says sine arc cosine x. So they want me to look first at the arc cosine of x. What that means is the cosine of your angle, and you can call the angle whatever you want. They called it u on the last question. I think your textbook calls it alpha, like I said earlier, but whatever. The cosine ratio is x, but I just said the word ratio, yet I did not write a ratio. Can you fix that for me? How would I write x as a ratio? X over 1. Very good. So I'm going to draw a triangle. Arc cosine is defined in quadrants 1 and 2. Which quadrant are we in? We're going to assume we're in quadrant 1 with a positive value like that. Yeah. All right. So remember the formula for cosine is x over r. Well, that's clever. They called x x. They called r 1. And they're going to want me to find the sine ratio, which is awesome, except y'all need to find a statement that represents that vertical leg. So here comes your Pythagorean theorem. You're going to set up x squared plus y squared equals 1 squared. And I need you to solve for y. So what would you do first? Subtract the x squared over. And I don't expect you guys to write out this like longhand, probably, you know, in your homework, maybe do one just so you know where it came from. I expect you guys to be doing a lot of this manipulation in your head. So now when you square root both sides, you just found out that this vertical leg is the square root of 1 minus x squared. Well, that's great news, except we haven't actually answered the question yet. The question says, what is the sine of this mysterious angle u? So the sine of u would be vertical leg over hypotenuse. So square root of 1 minus x squared over 1. Do you think you'd be wrong if you left your answer like that? I don't think so. It's a little overkill. What would normal people write? They would just write the square root of 1 minus x squared. They wouldn't say over 1. Okay. All right, next one. Start on the inside. It says you've got arcsine of x. So arcsine defined here and here. Since it's positive, we'll assume it's up here. But the sine ratio is supposed to be a ratio. So instead of x, let's call it x over 1. Now be careful here. Sine is vertical leg over r. So they're calling this leg x just to really mess with you. And then the radius is a 1. Could someone mentally manipulate this Pythagorean theorem and tell me what that horizontal leg is? 1 squared, so 1 minus x squared, square rooted, all that? Very good. So square root of 1 minus x squared. So there's your triangle. There's angle u. Now it says find the cotangent of that. So cotangent of this angle would be x over y, which I hate that they called it x, now I'm confused, but it's horizontal over vertical. So the square root of 1 minus x squared over x. Good news. Radical's not on the bottom this time, so you don't have to rationalize. This is your answer. Fun. Can't wait to do more of those. All right. You know, as I look at the next side of the worksheet, I'm kind of seeing more of the same. I actually don't see a single question that's, well, let's just do 2 real quick, because at least on that one we have to rationalize. So, start on the inside. It says arcsine x. So again, because of the positive nature, we're assuming we're up here in quadrant 1. If the sine of that value, the sine of that measure is x, that means I can write it as a ratio of x over 1. So again, they have the vertical leg called x, whoopsies, and then the radius is a 1. This is that same Pythagorean work you just did on the last question, so I'm just going to kind of steal that. This leg would be 1 squared minus x squared square rooted, so 1 minus x squared square rooted. And then it wants the tangent ratio. So the tangent would be vertical over horizontal, or opposite over adjacent. Well, why would your PreCalc, your calc teacher not be so happy with that answer? Not rationalized, so you'd hit numerator and denominator by this square root of 1 minus x squared. And the good news, guys, is you really don't have to do any math. This numerator, you just kind of write the multiplication side by side. We know that when you multiply a square root by itself, you're squaring it, so all you have left down here is 1 minus x squared. Don't try to do anything weird. A lot of kids try to like factor the denominator, and just trust me when I tell you, it does not cancel. Nothing simplifies. So once you rationalize, you're done. Okay? So your next assignment is going to be worksheet 22. I'm going to hand out a new homework check now. Y'all are going to get going on this because you have time. This is a blessing.